All right, so last class we were talking about, well, before we get there, we were talking about the battle, right? So we're looking at, it was an instance of, well, polymorphism, and refactoring and sort of taking a bad design and improving on it. And I just wanted to touch on one other thing, right? So I believe I did mention a few times about how ugly this code is. And so I just wanted to briefly talk about why and what we can do about it, right? So if you see something like this, like I'm exposing, basically I have a bunch of characters here, and I'm exposing a lot of character details. Like the is dead here is just the half of it. So this is a double for loop where every character tries to hit every other character. And so some of the details I'm exposing is this is dead function. I don't necessarily need to do that here. And this get hit, get swing, right? So now I'm exposing the fact that I'm using a swing object or whatever, at least, or that I have a get swing function. And the problem is that, like, if I want to change how these characters fight each other, then I have to come back here and change this code. But also, if I happen to like call these functions anywhere else, I have to go to all those other places and change them, right? So we kind of want, we don't want something that looks like this. Like here, I'm checking to see if they're dead, and if they're not, then I'm going to like have one swing at the other. But really, I want to hide all that. I just want, chars I get hit. Right? I'm just going to say this character is going to swing at the other character. And then what happens? All of these checks I can do inside this function instead of here exposed, confusing, right? Like, because I'm going down like, well, at least one level, right? So I'm going down into my attributes to get a swing class. So all of this could be changed to like one get hit function. And then inside this function, I could, for instance, well, we're going to change this to a character. And then I can handle all of the details inside that get hit function, right? So I'm not sure what it's complaining about, but I'm sure it'll be okay. Okay. Now I just have a very general function call. And inside here, I can do all of these checks. I could say, well, if I'm dead, I can return false, right? There's no fighting happening there. And if they are dead, I can also return false. And then here I can just say swing. I can make a temporary variable equals character. All right, I mean, I probably should use pointers here because I'm making a copy unnecessarily, but logically, now all of this works the same as everything that was exposed in my battle class before, right? So one of the big themes of this class and software engineering in general is like the complexity goes in where it belongs. And generally speaking, that's hidden away from your main algorithms, right? So now if I go back here, yeah, this is a lot more straightforward. I see a double for loop. I'm looping over this thing twice, and I'm seeing, oh, one character's trying to hit another. Like I can read that code now and it makes sense. Whereas before, I would have had to like try and interpret, well, it might be doing this, or like I'm checking to see if they're dead, probably. Like, why am I doing that? I'm not maybe exactly sure. But yeah, so that's, like I said, there's a lot wrong with this code, and there's a lot we can do to improve it. And but one of the just smaller things is that just watch out for stuff like I'm exposing too many details. I'm using too many getters here, right? Stuff like that. All right, questions? Okay. All right, so these next lectures are a little bit out of order from how I normally do them because I wanted to introduce templates early. because I don't know, maybe you're getting sick of all of these collection classes that you have to make. I know I am. And the next assignment, there would be 3 list classes you'd have to make. And I figured instead of doing that, we will just make 1 list template class, and then that can work for everybody, right? So if you're not familiar with templates, but that being said, going over the slides, I do notice that like, oh my, now I'm doing things out of order. So it's like some of the stuff might not make sense. So we're gonna be a little bit flexible about how we teach the next few lectures, but should be okay. So we'll give an overview of templates, and then we'll talk about function templates, and then we will talk about class templates, which is, similar to generics in Java. I mean, all templates are generics in Java, but it's C++, so we're talking about basically low-level templates, right? Like Java is sort of a high-level language that hides a lot of details, and the answer to everything is like, well, how the VM decides to do it, that's how Java does it. But in C++, we are doing things at a very low level, so we're going to see exactly how it happens. We're going to talk a little bit about the vector class. We might save some of that for when we get to operator overloading. But yeah, so one of the things we're talking about, well, data abstraction is one of them, where we're trying to add abstraction layers in the correct places so that our code reads better, and we can adjust it better, and we can reuse it better. So one of the things we want is to separation of abstract interfaces from concrete implementation, right? I just want some very general algorithms, and the implementations are found at runtime, and then that's very flexible code. Code reuse, right? Especially with collection classes, I shouldn't be writing them from scratch each time. We're doing that because I want you to understand how these things work. And if you understand how they work, then you're able to use them more efficiently. But in general, you don't want to do that. We would just use vector for all of the things that we have been done so far. Don't use vector, by the way, right? I don't know. Some of you have gotten dinged. It's at least 25%. The last 2 assignments has been 25% if you use the STL library, right? You're not supposed to use it for this assignment. The last assignment you can, well, I don't want to say for sure. Maybe you can use it on the last assignment. But yeah, so especially for collection classes, we want collection classes to be general. So mechanisms for code reuse, we use existing libraries, right? So the nice thing about existing libraries is that people have found all the bugs. And then also generic or template programming, right? So if I have a class that can work with multiple data types, well, that's great for me. I can just reuse that for all these different things, right? So instead of like what you guys are doing on assignment 3, which is you're making a repo list, which is a doubly linked list, and then you're basically copying and pasting that code into a file list, and then you're changing every instance of file to, or every instance of repo to file, right? That's a lot of extra work that as programmers we don't need to be doing because, well, actually it turns out computers are very good at doing that for you. So that's essentially what templates are, is that they're going to take that one class and copy and paste it into another class for you. And actually that is exactly what happens. All right, so templates are what we call generics in Java, right? And we will see why they call them templates, because they're not actually classes, I guess. But, so a template in general is something that establishes or serves as a pattern. So we're going to write code with generic placeholders for a type, and then later the compiler will come by and fill all of those types, those generic placeholders in with an actual type. All right, so in this approach, our data type is actually a parameter that we're going to pass in when we make our class. And yeah, technically, a templated function or class can be used with any data type, right? There's no restrictions in C++. You can put restrictions in Java, but in C++, it's going to try to compile it. If it compiles, great, you're good to go. If it doesn't compile, well, then, of course, you got problems. All right, so the first thing we're going to look at is function templates. So we're going to take a global function, and we're going to make it into a template. And yeah, well, let's start with that. And yeah, 1 second. Okay. Okay. So here's the code. We have a max function, so it takes 3 ints as arguments, and it returns an int, so it's going to return the maximum of those 3 ints. Okay, and so our main function doesn't do much. We just we call this max function and print out the result. Down here, if we look at the code, we make a temporary variable to hold the maximum value. We say, well, it might be the first value, so I'm going to start by assuming it is, and then I'm going to check to see, well, is the second value greater than this max value? And if it is, it becomes the new max value, and then is the third value greater than the current max value? And if it is, then that becomes the new max value. Okay, so simple algorithm. And so if we run this code, and yeah, it turns out that the maximum of 33, 22, and 44 is 44, just as we expected. Okay, so fine. But just having a max value that works on integers is maybe not enough. Maybe I also want one for floats, right? That makes sense. I can compare floats. It is obvious which is the biggest float. So I'm going to copy this function definition, paste it, and I'm going to replace all of the ints with floats. All right, and then down here, I am going to take this function implementation, and as it turns out, well, ints work with the greater than operator, and so do floats. So I'm going to just find every instance of int. I'm going to copy and, I'm going to replace it with an instance of float. And this still works, right? Because I can compare floats. And then I can go up here and do something like this. I can find the maximum float out of 31 or 33.1 and 22.3 and 44.5. Okay. And it works great, right? And the logic is all the same. All I had to do really, because the greater than operator works for both ints and floats. But of course, when I copy and paste things and do find replace, like I'm a human being and I make mistakes, right? You guys have probably seen some of the mistakes that I make in my specifications and things like that. This is not as reliable as it looks here. I did an easy example. For a more complicated example, it's easy to miss something. Fortunately, computers are very good at this, right? So what I really want is I want the computer to do this. I want the computer to say, like, if I need a max function for floats, well, it's going to do the copy, paste, find, replace for me. All right, so what I'm going to make is a templated function. So I'm going to do a template declaration. Type name. I think it's type name, pretty sure. I might be getting it confused with type def from 2401, but that should be fine. T is now my templated type, so I want a max function that works on the generic type T. Okay. What is T? Right now, T is nothing. It's just a placeholder. It's something that the compiler can recognize. And then I'm going to go down here and, well, actually, let's do it a little bit differently here. I'm going to say template class T. I don't need this anymore. And every instance of int just becomes this generic type T. All right, and if I run it, well, everything still works the same as before. So what exactly happened? Well, I told the compiler, look, here is a template. It's not actually a function. This function doesn't exist. Neither does this. This is not actually a function. If I compiled it without calling the max function, I would not have a max function compiled. But here I did actually call the max function with 3 ints. So the compiler looks and it saw this definition and it sees that, well, actually, I have something that matches that signature, right? So if I replaced T with int, then this would match this function signature and I would be able to call it. So that's exactly what it does. It does this, it copies this, it pastes it, it does a find replace T with int, right? And then so now I have an actual declaration here. So yeah, it'll do something like this. But now this is done by the compiler. And then down here, it sees, oh, I have another template. This actually matches that same function. So it's going to do a copy and paste and find replace with T with int. And then I'll have a max int function. And then when I come down here and it sees that, whoa, I made the same call with floats. Well, this actually fits the pattern of max, and then 3 of the same type. So again, it's going to do a copy and paste of this function declaration. It's going to do a find replace the T with float exactly as I did. And then it's going to come down here and do the same thing again. So, but now the compiler is doing it and computers are very good at this and very fast. So when I compile this code, I will actually have 2 functions max compiled along with my code, one for ints and one for floats. All right, questions so far? Okay, yeah, simple enough stuff. So, yeah, another max float. Let's do max characters. So I can actually pass in characters as well, right? Because, well, why is that? Well, actually, if I look down at, no, because I didn't do operator overloading, I can't do the time class, but that's hilarious. All right, so what the compiler does is says, actually, this does match the pattern of this. So it does a copy, paste, find, replace, T with char. And then it comes down here, copy, paste, find, replace, T with char, and then it tries to compile it. And is this going to compile? Well, it's going to compile if this greater than operator works with characters. And if it doesn't, it won't compile, right? So I can make, and yeah, it turns out the maximum character, well, characters are just, it's just their ASCII code, right? So they are numbers when you get down to it, and you can actually compare them with this greater than. So will this work? T can be anything, and as long as it matches the pattern and it compiles. So, in this case, I have to be able to use this greater than, but if I said, for instance, v2.print, well, then whatever I pass in better be able to print, right? And you can see the compiler here doesn't care because it says, I don't know what this type is. I don't know if it can print yet. But when I go to compile it, it's going to not be very happy with me. Yeah. All right. Questions? Okay. Yeah. I compare time objects. I guess not. All right. We'll come back to the, so here I've been doing it with just primitives. See, I knew this would happen, that because I changed the order I did things, now I can't do this, the rest of this example. However, let's say that I could somehow overload the greater than operator so that I can take these three time objects and do something like this. If T1 is greater than T2, whatever, print something or other. You can see here that, of course, I can't do that because currently, I don't have a greater than operator in my time class. But when we get to operator overloading, you'll see that we can actually add a greater than operator. And so if I could add a greater than operator to my time class, what happens is that I will be able to call this max function with I'll be able to say something like this. Right. So currently the compiler is fine with it because, well, this is just matching up with this. But when I go to compile it, I get this big, huge thing because it tries everything in its power to compare two time objects, converting them to something or looking for other operators. And but yeah, all right. So we'll come back to that when we get to operator overloading, but any questions? Okay. So yeah, that is a function template. So we need a template declaration on both the declaration and the implementation, right? The compiler has to know, they have to match essentially. So yeah, the idea is the thing that we did where we just copied, pasted, find, replace, that's now done by the compiler. And what happens is it only does that if I call that function with a type, right? Then it'll try and make a function of that type. And if I call it multiple times, it'll reuse the same function. But if I call it with different types, it'll make a new function for me. Okay, so yeah, calling the function using any data type. This is called a parameterized function. And yeah, I guess one of the things, I believe it's on the next set of slides. No, maybe not. Okay, so one of the things I'll draw your attention to is, maybe it's coming up later, but I used type name up here and I used class down here, right? Otherwise, it's the same. And it turns out for template declarations, it doesn't matter, which I don't necessarily like, but it's not really my choice. There is no difference using type name or class here, right? These do have different uses outside of this particular case. Type name actually does come in handy. I think we will see an example today. But in terms of template declaration, no difference. The other thing is I declared it with let's get rid of this stuff. I declared it with a T up here and a T down here, but I didn't have to. I could have done this. Actually, let's do this. Right, again, max value, did I not save it? Sorry? Oh, yeah, you're right. I missed one. Good eye. All right. Oh, there we go. All right. So yeah, because the T and the V are just placeholders, right? Again, it's going to be replaced with whatever type I put in. Also, the convention is like a uppercase letter or starting with an uppercase letter. I could actually use words as well, right? This is perfectly valid. I don't want to do that. Yeah, so I can use words. That will also work. But yeah, the convention is they would start with a capital, but you know, C++, anything goes really. Um, all right. And as mentioned, the big test is, can I use this type for this function? And the answer is, well, will it compile, right? If it compiles, you're good to go. If it doesn't compile, you're not. The compiler generates functions only for the types that appear in the code, right? You don't get anything for free because these are actual functions that it does have to make. So it's not going to make them for every single type. It's only going to make them for the types that I call. This does cause problems with the how we compile things, which we'll talk about in a bit. And yeah, the compiler does all the copy, pasting, find, replace, but it really is just a very primitive operation that it's doing. Okay, we can overload templated with non-templated functions. So yeah, let's see. Right, so I have this, and well, maybe for some reason, I also want to do a separate one for ints. Well, that's fine, I can do that. And yeah. Okay, so now I have, right? So when the compiler comes and sees that I call this with the ints, well, it's going to look, of course, this does match this template, but I already have a function that exists that will work for that. So, right, when we call it, it mentions that, yeah, we are in the int version, right? So it will not make a templated function if a function already exists for that type. Is there something else? I think that, yeah, I think that's it. All right, questions? Okay. All right, so that is function templates, important. But of course, we are interested in classes, and in particular, classes that can work with any type. So we also have class templates. Incidentally, the reason they're called templates, as mentioned, is that if I don't call that function, no function is made, right? No function is compiled. So these aren't actually functions. These are a template of something that can become a function if I put in a type that compiles, right? So that is why they're called a template. And it's worth keeping in mind that templates don't actually exist as functions. And class templates don't actually exist as classes, right? They are a template that might become a class if I can find a type that will compile it. If I can't, then it won't, right? So templates are not classes, they're not functions, they're just a blueprint for something that we can make. So our goal with a class template is to create a class that works with any data type, right? So we're going to give a type parameter to this class when it's declared. And yeah, it's similar to the functions. We're going to have just a T, for instance. Characteristics, well, once my class becomes templated and I have a parameter T, that parameter can appear anywhere, right? It can be a attribute, it can be a argument, it can be a return value. Any of those are fine. Collection classes are one of the most common uses of these templates, of course, because I want to store multiple things, and it makes sense to like store things in a certain order or whatever, right? So yeah, let's see. Let's look at a very simple templated list class. Well, actually, what we're going to do is this is a singly linked list class. Essentially the same code as well, not quite the same, but very similar to the code that we did when we took singly linked lists, right? And our singly linked list here stores book pointers currently, right? Otherwise, I think it adds at the back. I believe that's what this code does. Yeah. All right, so we're just going to add things at the back. We're going to remove them from, well, here we're going to remove them from an index. So I guess it's not quite the same. We're doing a little bit of different stuff, but kind of complicated. We have a print function. And then we have the book class that we're storing, which is, something we've seen before. We have a title, we have an author, we have an ID for our book. So we're going to make a list for our books. We're going to declare a bunch of books, and we're going to add them to the list. And then, I think I have a print function. Let's say list books. Okay, so let's make sure that that works. Okay, well, there's a lot of space there, but otherwise it seems to be fine. So I made these 4 books and printed them out of my list class. Yeah, so what we want to do is, well, that's great for books, but we want our list class to be a little more general. Maybe we want to, for instance, store some ints. So if I did list array of ints, then I want to be able to do something like this, right? I'm going to loop over a bunch of integers and just add them to my list. Of course, this gives me an error right now. So what I'm going to do is I'm going to make this into a templated type without changing any of the functionality, right? This is similar to what you will do in assignment 4, but you'll do it with an array backed list, right? So we'll do the complicated one here, and you guys can do the simpler one for your assignment. So to make a templated list class, well, that's pretty easy. I just add the qualifier here. And okay, so a lot of stuff just turned up red here. So obviously there's a lot of mistakes to fix. And what I really want to do is, instead of storing book pointers, I'm going to store this type T. Okay, so what does that mean? I'm going to, everywhere that I see this book pointer, I'm going to exchange that for T. And so yeah, that's fine there. Here, this should change to T. Right. My node, yeah, that's fine. Okay, all of a sudden this is no longer, the compiler no longer likes this. And the other thing you might notice is that I have the declaration and the implementation in the same file, right? So we'll talk about why we do that. And yes, for your assignment, you should do this for your templated list classes. But what the compiler is upset about is that list is no longer a type, right? Because now when I call list or refer to list, I'm actually referring to a list of a certain type. And here I used T, but I can't really use T here because the compiler has no idea what I'm talking about. So I have to actually say, well, oh, sorry, this is not a function declaration. This is a template of a function. Or sorry, this is not a function implementation. This is a template of a function implementation. And so if if ever you need this function, you should replace T with whatever type you're using. So whenever I refer to list now, I have to use the angle brackets. And if I have to use the angle brackets, that also means I have to declare a type. And in this case, I want to declare that it's a template. And then very easy, the logic should all be the same, right? So again, I want this to work with book pointers. So I don't want to change any logic. I just want to replace every instance of book pointer with T. And if I do that, oh my goodness, go away. If I do that, then when the compiler goes to make this class, it will replace T with book pointer, and I'll simply get back the thing that I had before. Okay, so Yeah, that should be okay. Oh, book pointer, I want to replace that with T and book with T. Oh, book here. That now becomes T. So in some sense, we're doing the opposite of the operation that the compiler is going to do, right? The compiler is going to take everything I just did and redo it and copy book star in there. I think that should be fine. Okay, so I got rid of all the red, so things are looking good. So now I don't have a class, I have a class template. So I do not actually have a list class. So I can't really make a list of books. What I have to do is I have to tell it what type you should go and find replace all the T's with. Okay, so I'm going to put book star in here, and then this code should work exactly the same. We'll comment that out for now. Oh, reverse, yeah. We'll come back to this in a second. Yeah, we'll revisit this. I think, so I wanted to demonstrate something about friend functions of a templated class. So we'll get back to that in a second. Okay, but otherwise my list function should work exactly the same as it did before, and it does. All right, but now I have, additionally, I can do stuff like make an array of ints. I have to specify that I want to store an int. Oops, no. Um, yeah, I love when I do that. Does anybody know how to switch to the other desktop? What was it? What did I do? Something like this. Uh, no. Oh, that's bananas. All right, so Windows, switch desktop. Task pane view and click on the desktop you want to switch to. What is the task pane view? Windows key, control left arrow. Ah, beauty. Okay. Jesus Christ. All right. Sorry about that. I'm clueless about desktops. All right, so I have my ints now, and I should be able to use this. I think we're good. Oh yeah, I should print out these ints as well. So list of ints. Oh wait, I don't need that. I just need. So what do we think is going to happen here? Are we good? No good. All right, so we have to be careful, right? Now that this is a generic type, if I look back at my list class where I want to print, well, I'm doing something, I'm not directly referencing a book pointer, but I am assuming that whatever I'm storing in data can use the print function. Okay, so it's nice to have these generic types, but also, on the other hand, we have to be careful about the things that we expect it to do. So now I can't use any data type here unless A, it's a pointer, right? Because I'm using this arrow, or it overloads the arrow operator, but most likely a pointer, and it has a print function. Okay, so now this generic print function it's no longer super useful to me. I would have to do something like, I could do something like this. This is a little more generic, but now I have to, well, let's see what happens. Well, it compiles. When I try and print out my books now, I get memory addresses. The integers work just fine, all right? So we do have to be careful about the assumptions we make when we make these templated functions. All right, questions? Okay. My brain is like not working. Oh yes, the reverse. Let's take a look at this reverse. So let's say that I had a global function that I wanted to call, and it reverses my linked list. And for whatever reason, it's not part of my list class, right? It's just some library that I'm calling. But in order to properly reverse my linked list, I have to have access to the nodes, right? I could do something very inefficient, like make a new list and all that jazz. But so what I want is, well, I have to make sure there's no such thing as a list anymore, right? So I have to use it as a list with something in here. But I put a T in here. Let's see what happens. I get a warning. Friend declaration. I haven't done anything wrong just yet because I have no, but it's telling me if this is not what you intended, make sure the function template has already been declared, blah, 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 blah. So what I have to do is I have to say that this is actually a function template as well, right? So I have to, when I go into my reverse, well, this is a global function that works on my list class, but I don't want to declare the type I'm using, so I'm going to make it a class T. And yeah, so I'm going to reverse some list with some type not quite named. And well, that's just the beginning of our problems. Also, when I declare it here, this is like the, right, we talked a little bit about how this is a weak forward reference, right? So this is like a function declaration of a template. So I actually have to make this a template as well. Okay, so I'm declaring that this friend function that I'm declaring forward referencing here is a templated friend function. And yeah, I'm going to get a lot of mistakes here. So one of them, this is that this T templates shadows this T, right? So remember when we talked about scope, variable scope? Well, that does apply to these templated types as well. So when I declare my entire class has a template type T, and then inside here, I use this, I redeclare this type T, which means that now it can no longer see this T out here, right? So when I do something like this, I want to change the type, just the variable, right? Just the variable name so that it doesn't shadow the outside T parameter. Okay. Questions? Okay. There's a bunch of other stuff that went wrong, so yeah, it doesn't like all this. Let's see if we can fix it. So the problem is in my, here, you can see that these are all white because, well, the compiler doesn't quite know what to make of this. It turns out that using a templated type, first of all, I should do this. This might fix some of it. But yeah, I still get current node was not declared in the scope, right? Because it's it turns out that this syntax is ambiguous, and it doesn't know if I'm declaring a node pointer or if I'm saying take some variable from my list class and multiply it times this, whatever this is. So I actually have to use type name here. And then I'm giving the compiler a hint that, no, this is not a multiplication operation. This is actually a type. And if you're confused, well, join the club. I'm not exactly clear on, if you have a problem like this, maybe try type name and that might fix it. And essentially the problem is that written like that, it can be ambiguous. For me to come up with an example where it is actually ambiguous, I don't know. I would have to study a little more. But yeah, now that I put type name in here, well, then now the compiler knows that this is a type and that I mean pointer, and then it can resolve the rest of the problems. All right. I guess we could test this. I don't know. I had Copilot write it. Does the code look right to you? I don't know. It's like, I didn't feel like straining my brain on a Friday afternoon trying to reverse a linked list. I think this would work, but all right. Questions? Okay. So a lot of details there. You don't have to remember all of them. You just have to remember like, there is a pitfall. And if you happen to fall in it, you know sort of where to begin looking for a solution. That's the idea. So yeah. Oh yeah, the other thing, it's all in one class, right? So if we separate this list class into a header and source file, what's going to happen? Well, in particular, what happens when I call this? Right? So it's going to take list.cc and try to compile it. And the compiler's dumb. It's going to, presumably I've included list.h at the top. So when it starts reading list.cc, it's going to read list.h and it's going to see my class declaration, but it's not actually a class, it's a template. And so the compiler can't compile this into code because it doesn't know what type T is, right? So that's the issue. So the solution, or at least one solution that we are using, there are other solutions, essentially is that, well, I'm just going to make this a header and I'm going to put the implementation in with it. And then if I need it somewhere like here, well, I include list.h. It also has the implementation. And then when I do this, the compiler has all the information it needs. It's going to copy, paste, find, replace. It's going to compile this class. It's going to see that it compiles, and then it's going to be able to use it. All right. But if I listed the implementation separately, it won't be able to compile it against this type because it does not know what type I need, right? It doesn't know what types T is going to be. It might have to make like a dozen classes, and it doesn't know that. So in order to solve that problem, when we use templates, just keep everything in the same file. It's just easier that way. There are other solutions if you want to explore them. Again, the sort of guideline is if it works, fantastic. As long as you don't, use the STL library when you're not supposed to. Questions? Okay. All right. The other thing we saw is that if I have a friend declaration inside, well, and if it's a templated function, right? It doesn't have to be. I could have written reverse and said, only reverse a list or an array if it's for book pointers, right? And then it won't work on the array of ints, but it'll work on my book pointer array. Or I can say, well, it's a templated function as well. And if I do that, I have to use the template declaration, but I have to use a separate letter from this. Okay. Also, this we talked about earlier, right? So these two things mean exactly the same thing in terms of declaring something as a template. They are not interchangeable in other places, as we saw, right? In our reverse function, in order to properly identify that a node pointer was a node pointer, we had to include the type name. Again, it's complicated. I'm not, if you ask me details on that, I could do my best, but that is a little bit deeper than I've gone so far into C++. There is a Stack Overflow post if you're interested, outlining some of the differences between class and type name and some of the use cases. Okay, so yeah, what do? We write the class for a class template, with some placeholder like t as the data type. And then somewhere in our code, we're going to declare an instance of the class, right? The same as the function. It's not a function until we call it. A templated class is not a class until I declare an instance of it. And then when I do that, the compiler goes, okay, let's see if this works. And then does a copy, paste, find, replace, tries to compile it. And if it compiles, you're good to go. And if it doesn't compile, well, then you have to fix it. And also, right, when I made that list class, I made a list of book pointers and I made a list of ints. And the compiler created two classes, right? Those are different classes. So I no longer have just one list class. I have two or as many as I declare. If I declared two lists of book pointers, those would be the same class, right? If it matches the T, then that's something that the compiler already made. It's going to reuse that class. And then, yeah, the newly created class is compiled with your code, and then you're good to go. All right, so we're going to look at some special cases. We can have multiple types. We can actually have non-type parameters. We can actually pass in variables, and we can have default types. So yeah, let's see some of these examples. So yeah, we are going to, well, let's take a look at our map item class. Map item class is simply like a little mini dictionary object, right? It's a key value pair. The key in this case is an integer and the value is a string. So we're going to map some set of values to some set of strings. And there's a set function that assigns, k to the int and v to the string, and then a print. So we're going to make an array of these map items, and then we're going to set them to a bunch of hockey players and then print them out. Like, yeah, map items have a print. Okay, great. So now what we're going to do is, well, that's all well and good as long as I want to have ints as the key and strings as the value. But maybe, for instance, I want to have some grades where I set the student name to some GPA value. What I want is I want a generic type or a templated type that takes two templated parameters. So this declaration, template, class K and class V. And now my class is a templated class, which means, well, this is a little preview to operator overloading. Just as a reminder, though, if I, for instance, well, it doesn't make sense to reverse a map item, but let's say I said, I foo my map item. Right, so I made a friend declaration. Well, I have to actually, that is going to be a templated type, but I can't use K and V. I have to think of something else. So like maybe P and Q, right? Otherwise, they're going to shadow those ones. And then here I would put P comma Q. Okay, so yeah, for multiple templated types, again, I have to be careful not to shadow the parameters on these friend declarations. We do not have a function called foo. So now we're just going to take every instance of int, replace it with k, and every instance of string and replace it with v. And well, we are making an assumption here. We are assuming that these things can be printed out to the standard output using the stream insertion operator. But most things that you'll find in C++ can do that. The things that we built so far cannot, but they will be able to shortly when we learn how to do that. Right, this is now there's no such thing as a map item anymore. There's only a map item KV, set K and V. And yeah, so that looks good. So yeah, we have a templated map item with 2 types. So now we have to explicitly say that this is an int in a string of the max size, but otherwise everything should work exactly the same. And voila. So our hockey players, very, very old hockey players, but hockey players nonetheless. All right. So yeah, let's, the last thing is, it doesn't like that. Grades by print. All right, so now we can use a map, an array of map items for different things, like holding GPAs of students. And now my key is a string and the value is a float. All right, questions? Okay. So what else can we do with these templates? Well, let's say instead of making a, instead of making an array of map items, I kind of want to make a specialized class that holds these map items for me. And then I can call something like map.add, 10 Bobby, etc. Okay, and we actually have an instance of a map that'll do that. It works on an int and a string, and so, well, what we're going to do actually is say map. Wait, how big do we want this? And yeah, this is going to be, I don't know, we should probably, let's say, define max 10. So this will be an array of 10 elements. And then we can say, well, should we add this, right? Well, if, sorry, size equals 0, we want to initialize that. Say if size greater than or equal to max, we'll simply return or exit. Maybe it's too full. Let's call exit 1. Otherwise, we're simply going to set items set, yeah, sorry. Set key value. And then print, I need a, okay, so now we have a working map, presumably. I think I have, sorry, map.h. Oh. Okay. All right. So great. We have a map class. So now maybe we want this map class to be templated as well. Not super difficult, right? But maybe we want some different, I don't know. We can make a map of like strings versus strings. So I'm going to actually make this also a templated type, and it's going to contain another templated type, class K, class V. And now this is going to be K, V, and down here, I'm going to use K and V as well, right? So when I declare a templated type within another templated type, if I want to use the same types, I can, right? So there's not an issue here. Not to be confused when we had our friend declaration and we had to use a different pair of variables. Here, I actually want the same pair of variables, right? Again, if you think about what the compiler is doing, it's doing a find, a find and replace on these with whatever the values are. And so we want this K and V to match this K and V and this K and V. But of course, we have to do that all the way down. Okay. Oh, yeah. And the last thing I have to do is int and string. Okay, so everything's working fine. And also, if I wanted to, I could make I could do something like this. I could say string, string. And then I could just make these into strings. And works just fine. Okay, so yeah, templated types can contain other templated types. And I didn't have to use KV there, but I wanted to, right? I could have declared this, I could have hard-coded this or whatever. But any questions? Okay, so another thing we can do with this is, well, actually, so we've been using class or, type name, which is the same in this context, but right here I'm declaring it has a max size of whatever max is, but max is hard-coded and maybe I want to have it have different sizes. All right, so instead of using this max, I'm going to get rid of this. I'm going to add a third parameter, capacity. And it turns out it's not going to be a class type, it's going to be an int type. Because these are just parameters in some sense, right? I can pass in any values that I want. So here I'm going to accept an int. Of course, this messes up a bunch of other stuff, but well, first of all, what do I put here? I can put capacity, right? Once the compiler does its find replace, it's going to say whatever I pass in here, it's going to paste into here. And then this will be hard-coded for this particular class. But if I declare a different class, I can do something different. Of course, all my templates now have to look like this. And of course, this also has to include that third parameter now. But otherwise, it should work fine. Of course, I need a parameter here now, so I can say, let's say 4. That size, yeah, max. Where is that? So now here I can also use the capacity, or in this case, the C, right? Because I declared it as a C here instead. And when the compiler comes through, it's going to replace that with a hard-coded value. Okay, and now everything works just like it did before, except that now if I try to add a fifth person, Sue, yeah. Well, first of all, make sure we're passing in the correct types. Yeah, so it exited quietly. We could change that to give us an error message. right? We don't really want to exit quietly. That's something that, you guys see enough in like COMP2406, I'm sure. We want to announce when something goes wrong so that we can debug it. But yeah. All right, questions? Okay, so last thing, 8 minutes left. So if I look at this now, my code, well, this has like, we can get carried away here maybe with the number of parameters that we're passing in. Incidentally, we change this to 5, that should work, right? Perfect, okay. So maybe we want to say, well, the same as when we pass in parameters to a function, we want some of them to have default values. Okay, so what we're going to do is say, well, maybe by default, I want to store 5 people. Oh, whoops, wrong one. Maybe by default, I want to store 5 people. Okay, and now I still have to, declare my templates in the function declaration or function implementations in this case. But when I come to declaring the class, I can just say, well, I'm not going to bother with the capacity. You just use the default. And lo and behold, that will work. And the same with function default arguments for functions. We can do more than one. Right? I can say that, well, by default, if I don't declare what value it is, declare it a string. Oops, wrong one again. Declare it a string. Okay, so that means that, and here, I can declare it an int. Or, well, yeah, let's leave it an int and see what happens. Okay, so that means that I can leave out this argument too and just say, well, I only want to define the first one as being a string. And yeah, that still works. Or I can leave it blank. But now you can see the compiler's complaining because, well, by default, this is going to be an int, and I have all strings here, so. So I can solve that problem. All right. Okay, so default arguments, questions on that? Okay, so one more thing before we go, and that should wrap up this topic. Well, yeah, pretty close. So one thing to watch out for, however, is, okay, so I declare a map that looks like this. And let's say I declare a second map that looks like this, map 2. Okay, and if I go into my map class, well, I have not here, but I'm going to make a static int capacity for some reason. Cap. Okay. And in my in here, I'm going to assign it the value that I passed into capacity. Okay, so it's a static variable, which means it takes on the value of for every class, it's the same value, right? And it's public here. That means I can access it. So I can do something like oops. Capacity map 2. What did I do here? Perhaps. Oh, I think I have to do this, eh? I think I have to initialize it outside. And declare it as a template, which means that I have to do int. Let's try it like that. Okay, so the capacity of both is 5, and if yeah, that's and yes, if I have a static variable, this is how I initialize it using templates. So useful lesson there. But if I say map.cap equals 10, and then I print them both out again, well, you can see that they both changed, right? So they are the same class, right? They have the same class variable. If I do something like this, say this one now 6 and this one 5, well, that's just one little change, but right now capacity of map is 6 and capacity of map 2 is 5, and I changed map to 10 and the capacity of map 2 is still 5, which means now that just because I changed that parameter, now I have two different classes, right? And you should think very hard about if that's what you want. Maybe, but if you have any static variables, you have to realize that now these are different classes and you may not get the behavior that you want. So yeah, that is everything you ever wanted to know about templates. Questions? All right, so yeah, your next class, or sorry, your next assignment, you will be using templates. It will make your life easier after you get over all the hiccups. But yeah, that's it for today. Yeah, get your assignments in, get your tutorials in, and have a good weekend. I'll see you next week.